Okay, arcs and chords. We start with this, the congruent arc theorem. We're going to talk about what constitutes congruent arcs, and we're also going to look at the chords that connect the endpoints of those arcs. So you take any arc on a circle, you take the two endpoints and you connect them, you get a chord. And sometimes that chord passes through the center of the circle. Most of the time, however, it won't. And so we've got this relationship there that if the chords are congruent, then the arcs are congruent. If the arcs are congruent, the chords are congruent. So it's pretty straightforward. Remember, the if and only if means it's a reversible statement. So again, chords congruent, arcs congruent, chords congruent. The important part of that is the first sentence, in a circle or congruent circles. If you have different size circles, this all falls apart. Are you leaving?
No,
Well, thanks for coming today. See you later. Bye. You want to take your stuff with you? Oh, you should. Sorry. You should start. First circle, 250.
That's not.
What?
Can you go back?
Yes? Sure. Are you matching the font, or
No, I just.
are you drawing the little purple rectangle up in the corner?
It took me a while to get my notebook out. Alright, you can go.
Gee, thanks. First circle over here on the left, 250-degree. What kind of angles are these called? What kind of angles are these called? What kind of angles are these called? I'm sorry?
Adjacent.
What kind of angles are these called? I'm sorry? Central angles, thank you. They are not vertical angles. They're not minor angles. We don't know what a minor angle is. Arcs are minor, not angles. These are two central angles because the vertex is located at the center of the circle. And therefore, they generate two arcs, AB and CD. Are those two arcs congruent?
Yes.
Yes.
Carter,
Yeah,
why?
because it's in the same circle. and
So?
It's the same angle, which means that since it's the same circle, means that they're gonna have the same circle.
Okay, how about these two?
You don't know.
287-degree angles, central angles, generating two 87-degree arcs. Do you agree that this is an 87-degree arc?
Yeah,
Do you agree that this is an 87-degree arc?
yeah.
Are these two arcs congruent?
You don't know.
You don't know.
No.
Why, so how?
Because one circle could be bigger than the other.
There's nothing in that picture that indicates that those circles are the same? They look the same. Think those circles are congruent? No? You sure? They look the same. But no.
The rule
What
is
makes
that-
you say no?
The rule is it has to be in one circle.
Or,
Congruent circles.
so then you're saying those circles aren't congruent.
But how do we know if the lower circle is bigger than the circle on top?
We don't. So you're saying they're not congruent.
They can't measure it.
They can't be congruent. You sure? Positive. Want to bet 10 push-ups on that?
Sure.
So let's just make sure we understand this
Yeah.
before I get out a ruler.
Every day.
You're saying that these two circles cannot be congruent.
Based on the theorem.
Well, but I didn't tell you
Oh.
to do anything.
Yeah.
Yeah.
Give me congruent.
It could be, there's no.
Yeah, I
evidence.
think we're gonna-
There's no evidence saying they are, but they could be.
They could be.
It could be.
They could be,
Yeah.
but they don't have to be.
No.
It could be.
No, they have to be.
Yes.
Yes.
Yes, they have to be.
No, they can be. If more information was given about the circle, they can be. But at this point, we cannot assume that it is, or that they are both congruent.
Sounds rich.
So what's the answer to the original question I asked Carter? Are those arcs congruent?
We don't know. We do not have enough information to solve that.
Correct. That's the correct answer. The answer is not yes or no, it's we don't know. Because they might be congruent, like you said, they might not be congruent. If they're congruent, would the arcs be congruent?
Yes.
Yes.
If they're not congruent, would the arcs be congruent?
No.
No. Okay, how about the one on the far right? Two arcs. How big is arc AB?
72.
72. How big is arc CD?
72.
So therefore,
Not
Oh,
but they're both 72 degrees.
but it's two different shapes.
Pat?
It says in one circle or in two congruent circles.
So not congruent.
They're not congruent.
Left one must be congruent. Are we in agreement?
True.
Middle one, we have no idea.
True.
Right one can't be congruent.
True.
Good. All right. Now we take a chord and we put a segment through it, and in fact we put a diameter through it. Excuse me. If the diameter is perpendicular to the chord, you can see a little box down there in the corner. It bisects the chord and bisects the arc. Alec, put the iPad away. Attaboy. Good job. Is the converse of this theorem also true?
Yes.
What would the converse be, Max?
If the chord and the arc are bisected by the diameter, the diameter is perpendicular.
Close. Michael?
If the diameter bisects the chord and its arc, then the diameter is perpendicular to the chord.
That's what he just said. So this one, we're starting with a diameter that's perpendicular to the chord. And if those two things are true, it's a diameter and it's perpendicular, then it bisects each of the two things. So what would the converse of that be? Pat?
If the diameter is not perpendicular to the chord, then it doesn't bisect the chord and its arc.
That's an inverse. We don't want to negate, we want to reverse. Kelly?
If a diameter bisects the chord and its arc, then it's perpendicular to the chord.
Nope. Close.
If the chord bisects that diameter and.
Nope. Carter?
If a line bisects the chord and the arc, then it is a perpendicular diameter.
Then it's just, okay, so it's
just the diameter.
close enough. If it's perpendicular and it bisects, in other words, it's the perpendicular bisector of the chord, then it's a diameter, or that it passes through the center of the circle. Okay. Same picture, different starting information. The first one we started with a perpendicular diameter. This one we start with a perpendicular bisector. Both cases they're perpendicular. One of them starts as a diameter and bisects. The other one bisects and gives you a diameter. So this theorem would allow you to find the center of a circle if you didn't know where the center was. Can you visualize how that would happen? Yes or no? Or some type of response would be good. A grunt, maybe a... Thank you. We have a circle, and we don't know where the center is. And I want to find the center. How do I find it? All I need to do is draw in a chord, find the perpendicular bisector, and obviously I would do this with a pen that works, or something more accurate. Would that tell me where the center of the circle is?
Not yet.
Not yet, so I do it again. Draw another chord, find the perpendicular bisector, and where those two meet gives you the center of the circle. Okay?
Whoa.
If two chords are congruent, then they're equidistant from the center of the circle. Well, how do we measure the distance from a point to a line or a point to a segment? Remember, we always measure along a perpendicular. Burst into flames, run to the river. Remember that?
Yeah.
No, you don't remember that discussion? You're at the campground, you burst into fire, there's the river, where do you run?
Straight line.
You run in a straight perpendicular distance to the river? Yes, sir?
But if you're on fire, like, technically, wouldn't you be like days?
Oh, here we go. What?
Well, I'm just saying, like, if you're on fire, you'd be like.
What would be
freaking
your
out.
first thought if you were on fire?
Get
Stop,
out.
drop, and roll.
Stop, drop, and roll.
No, your first idea would be to get this fire off of me, so
Thank
I
you.
wanna
Yeah.
extinguish it.
Then you would go through the process of,
Well,
well,
actually,
how
my
could I
first
do
thought
that?
would probably be,
I could
I'm
stop,
on
drop,
fire.
and roll, or I could run to the river, because there's a river right over
It's
there.
just be, I'm on fire right now.
So,
If you
let-
think
let's,
you could,
all right,
if
let's
you think
change,
you could make
You
it to
could
the
roll
river,
to the
then you
river.
would stop, drop, and roll.
good,
You could roll to the
But
river
okay,
to
okay,
make it more like.
excellent. You could roll to the, and if you rolled to the river, what path would you take? You would travel along a perpendicular.
Unless you can't like, you don't know which direction you're going when you're like turning, so you could like accidentally run that big.
If you're going away from
Cover me in kerosene, light me on fire. told you
Excellent
it wouldn't
point.
work.
So therefore, let's forget about the whole burst in flames run to the river, and just remember that you measured the distance from a point to a segment or a line along a perpendicular, and therefore, if those two chords are the same length, then these two distances are going to be the same, and if these two distances are the same, the chords are the same length.
So we're technically just switching these up. It's just reversing.
Not really. These two are reverses. This is something new because this is comparing two new chords.
Okay.
This one is all based on one chord. Okay, that didn't work. Let's try this. Do you know what a grain silo is?
Yes.
Okay, you.
what kind of?
No.
No.
It's the big things that's by the farm.
It's the big things by farms, the big cylinders.
That.
They put grain in there.
Really?
I
I didn't know what they are, I didn't know that there was grain in there.
Yeah, they use those to store grain.
But if they, if you have a door on them, if they open the door, it wouldn't always come out.
Yes, so there's a simple solution to that.
Don't open the
Don't
door.
open the door. Yeah. So you have an empty grain silo and you have a very long stick in your hand. I don't know why you have a very long stick. But if you want to run towards the wall of the silo with a stick in your hand, you're only going to get so close because eventually the stick's going to hit the walls and stop you from smashing into the wall. This is a much better analogy, right? This is much clearer than bursting into flames and running to the river.
It's heavy.
So no matter where in the grain silo you decide to run into the wall, you're only going to get so close to the wall because you have a stick in your hand.
You could be blind.
Obviously.
Yeah, so that clears everything up, right? So we're good?
We're good.
I'm sorry?
Is the stick flexible?
No, it's a titanium rod.
What if you hold it?
I'm pretty sure everything has a breaking point. So.
You were out in the field playing with a titanium rod and a lightning storm came about. You got scared because you have a giant titanium rod in your hand.
And then
So
you
you
went
went to
to a
seek
metal
shelter in the silo, but the roof from the silo is missing. The hemisphere from the silo is missing, and you're afraid lightning's going to come down the silo. So you want to get closest to the wall as possible, but you realize that the titanium rod in your hand will only allow you to get so close to the wall.
Wait, you can never let go of the titanium rod.
If you got, what if the titanium
Oh
like
my
rod got struck by lightning, you would burst into flames after running to the roof?
Oh!
You don't necessarily, just because you get struck by lightning doesn't mean you would burst into flames.
Or maybe
You could, right,
You could cover that.
right.
Spontaneous combustion.
You get
Exactly.
tomahawked like that one book. Remember we read
You get to a
it?
point where you just feel like you've lost all
Football
control.
field.
Suppose a 10 centimeter chord
I think that was IR.
is 12 centimeters from the center of the circle. Or you have a 10-foot titanium rod in your hand and you are 12 feet away from the center of the silo. What is the exact circumference of the silo? AKA circle. Question?
I think I know.
Oh, do tell.
24.5.
Nope.
Oh.
Nope. Nick, what are you doing? Practice running towards the wall?
Yeah,
Uh-huh.
but I have to hold it, so it's this.
I understand, that's better. If TR is 10, what else do we know? Zach?
TE would be 5 and ER would be 5.
Say that again.
Oh.
TE would be 5 and
ER would be 5.
good. What else do we know? Oh, we know GE is 12. If I want to find the circumference, I need either the diameter or the radius. How do I find the radius? Radius.
That was cool.
Yes, sir.
And that'll equal 13.
It will equal 13. It's a 5, 12, 13 triangle. Well done. Or did you do 5 squared plus 12 squared equals GR squared? Attaboy. And therefore the answer is 26 pi. Circumference is 2 pi r. 2 pi times 13 is 26 pi. Which realistically speaking, if you're talking about the circumference of a silo, no farmer is measuring the circumference of his silo by 26 pi. They would multiply that out to be approximately
81.68.
81.68. In this case, it's centimeters, but we were talking about feet, but we'll go with that. This is a common technique, drawing in a radius wherever you need it. Wilma has a question.
If you were in the grain thing, wouldn't technically be covered by grain? So like
No, I started by saying it's an empty grain silo.
Why don't you just drop the rod and just?
Because it's
But it's glued to your hand.
You don't
Yeah.
understand.
Oh.
You are
Gorilla
titanium.
glue and duct tape.
I'm sorry, Gorilla Glue and duct tape. Just in case the Gorilla Glue, I can't even say that, Gorilla Glue.
Gorilla glue.
Gorilla, Gorilla Glue,
Oh, you're
Gorilla Glue. In case that breaks down, you've got the duct tape to ensure that you don't drop the titanium rod.
how heavy would a titanium?
Break it down.
Titanium's pretty light. It's lighter than steel, yeah. So you'd be
I
fine.
don't even know how
What
much
about lead?
steel is.
A lead rod.
No, it'd be heavy, but it'd be like really
Dirty.
flexible and
It just snapped.
it would bend when you come into the corner.
What about aluminum?
But there are no corners on it.
I'm sorry?
There are no corners.
Excellent point, I misspoke. It would bend when you come towards the wall, not the corner, because it's a circular
You can
silo,
turn
it
your
has
head
no
like
corners.
this.
Or, it has an infinite number of corners. Yes, sir.
Are you holding the rod like this?
Or like this, or like this.
Or like this.
Or like this.
Not like this.
This.
You'd impale yourself. You can't run like this. You're not jousting. You're not gonna get close to the wall going like this, you have to turn it
But you
sideways.
can just oval
Wait, but
over
then
the
you-
top.
No, you can't. You can't turn it upwards because you're balancing
Monkeys.
you're balancing some birdies on it that you're trying to save their lives from the lightning
Then
storm.
why would you jab into a wall?
I hesitate to do this, but yes, Rich.
What if it's adamantium?
What?
It's from
Good.
X-Men.
It's a good point.
I think I know.
Yeah.
Like we
Then
cut
you
through
just
the
punch
silo.
through the side
Yeah,
of it.
exactly.
Yeah.
Exactly.
Yes, Kelly.
If you were holding it like that, you wouldn't run into the wall. Yeah.
That's the whole point.
You want to run into the
You
wall.
can't run into the wall.
Wait, so is
It would look like TR.
How strong is this silo?
I.e. the path of travel?
IE is the, right, so here's the door to the silo. I is the door to the silo. You come in, lightning strikes, you're afraid, you run across the silo. G is the center of the silo. And then you get to E. When you get to E, the rod, TR.
Jesus
How would
is
you
the
have
center
gotten
of the
silo?
And then you run straight into a wall. Jesus to a wall.
But yeah, how could you
No,
fit
you-
yours? Then you hold it next to it. Like this.
Yeah.
He
He just asked the question, same question, and
He stumped him.
I don't have an answer.
Yeah.
Well,
You
look,
brought it in sideways,
Yeah,
like
you
this.
can balance the birds like
But
that.
how did you get
And then
in?
turn.
I mean, how are you gonna?
You open the door and walk in.
How do you
Oh,
open the
you
door?
get-
Could you do the same
Doors
thing to get
are
out?
open on a silo.
Huh?
Could you-
Yeah, but you don't want to go out. There's a lightning storm going on.
Wait, so you're trying to get close to the wall? You can.
Yeah.
Oh, okay.
Safety
I was
first.
so lost.
But now you're found.
With the
How can you open the door? Your hands
It's
are
already open, right, Nick?
Circle P. So, I don't always do this, but I should. That this statement is going to tell you two things. What are they?
That is a circle.
Number one, it's a circle. Josh?
He is a center.
P is the center. Good. EF and GH both equal 24. So now you have a 24-foot rod in a silo. It's a big, long titanium rod. What does this tell you? And don't tell me that it's 24.
Then a, yeah, GH or.
Yeah, the chords are congruent. And if the chords are congruent, what then must be true? Nick?
The distance, the perpendicular bisector to P is
Be specific.
QP and PR are congruent.
QP and PR are congruent. Set them equal solve for x, plug and chug. And PQ is how much? Yes?
9.
9. Yes?
I don't
Yeah.
know, I was still drawing. Yeah, me too.
Still drawing.
I was drawing a picture too.
Speed demon over here.
So 320. Yeah, x is 3. Question?
It is a Saturday.
Correct, that's why we're celebrating it on Friday.
Set them equal.
Naysayer.
Oh,
Five
okay.
X.
Yeah, I got you.
If I know that PQ is, what'd you say, Nick? 9?
Yeah.
How do I find the circumference?
Ooh.
Emma?
You do the same thing as last time, where you do Pythagorean theorem and do radius.
Which one would you like to draw in?
EP.
EP. Okay. How long is EQ? 12. Because if this is perpendicular to the chord, it bisects the chord. 9, 12. Question or answer?
How do you find PQ? I didn't.
These two have to be
15.
congruent.
Oh, so you just
Set them equal solve for x. And then plug it back in. It's 15. It's a 3, 4, 5 triangle times 3, or 9 squared plus 12 squared equals 15 squared. And therefore the circumference would be 30 pi.
Judy J. Judy J.
Have we seen this one already?
no.
You haven't seen? Oh, okay. I'll play it.
It's fine.
Day job orchestra.
For some reason, this just cracks me up. I don't know why.
Oh.
That's all it is.
That was fantastic.
It's gonna be a pretty interesting video.
Do you want a treat?